Next, we are looking at a couple definitions. The level of confidence C is the probability that the interval estimate contains the population parameter. For critical values, the level of confidence probability corresponds to the area under the standard normal distribution between two z-scores. These two z-values, negative zc and positive zc, are called critical values. So in the table, for each level of confidence, so 90%, 95%, and 99%, we have corresponding critical values, 1.645, 1.96, and 2.575. So these really come from the inverse norm. So for example, if we had a level of confidence of 90%, C would be 0.90, and the remaining area would be 1 minus 0.90, which is 0.10. So then we would have to divide this by 2 to find the area in each tail, and that would be 0.05. So to get negative ZC, we would take the inverse norm of 0.05, and that's negative 1.645. And then the positive version is positive 1.645. The sampling error is the difference between the point estimate and the actual population parameter value. The margin of error E is the greatest possible distance between the point estimate and the value of the parameter it is estimating, given a level of confidence C. So the formula is E is equal to ZC times sigma divided by the square root of n. And this formula can be used when the following conditions are met. So the population standard deviation needs to be known. The sample is random, and then at least one of the following is true. The population is normally distributed, or the sample size n is greater than or equal to 30. A confidence interval uses a point estimate, a margin of error, and a level of confidence to construct an interval estimate of a population parameter. The probability that the population parameter is within the confidence interval is C, assuming the estimation process is repeated a large number of times. So the confidence interval for the population mean is mu is between x bar minus the error and x bar plus the error. In a random sample of 60 refrigerators, the mean repair cost was $150. The population standard deviation is known to be $15.50. Construct a 95% confidence interval for the population mean repair cost. Interpret the results and show all work. So n is equal to 60, x bar is 150, and sigma is 15.5. So we know what sigma is. The sample is random, and our sample size is 60, which is greater than or equal to 30. So we can use the margin of error formula. So we need to find ZC. So if we look at the table for a 95% confidence level, then Z of 95 is 1.96. So the error is 1.96 times 15.5 divided by the square root of 60. And this is equal to 3.92. So now we can construct the confidence interval. So mu is between x bar minus the error and x bar plus the error. So 150 minus 3.92 and 150 plus 3.92. And that is equal to 146.08 and 153.92. And in interval notation, that would look like this. So what this means is, with 95% confidence, we can say that the true population mean repair cost is between $146.08 and $153.92.